Good morning, mini mathematicians. This is Mrs. Barr. Today we're going to be doing the 5.2a lesson, Scientific Notation. And I need you looking at page 28 in your module and have your notebooks open. So let's start our notebook entry. So you're on page 28 in your module and you're open to a new page in your notebook. And we're going to be doing 5.2a, which is scientific notation. In your module, this is pages 28, 29, and 30. We'll also be doing the extension on page 31. So let's fill out today's purpose. Our lesson purpose today is for you to know what scientific notation is, the form, and be able to go from standard form which is the decimal expansion, to scientific notation, and vice versa. Also, explain why a number is or isn't or is not written in scientific notation. And then we'll start our notes. Give you a moment to make sure you have all of that written down. And then we will move on. So the big question today is, what is scientific notation? Well, if you look at page 28, you will see a paragraph that explains that we really like to be efficient when we are communicating. So when I'm doing math with really huge numbers, like in the trillions and quadrillions, or really super small numbers, like in the millionths or trillionths, when I'm working with those types of numbers, it's really difficult to deal with that many zeros. So we write numbers in scientific notation to make the math easier. So something we need to look at is, what is scientific notation? So scientific notation is any number written in the form a times 10 to the n. And there, of course, there's special values that a can be. A is called the significant figure. So significant, it's really important. Figure, it's just a number. It's a really important number, and this number has to be greater than or equal to 1, but less than 10. So it can be 1, it can be 1.1, it can be 1.001, it can be 3, it can be 3.05, it can be 9.999999999, cannot be 10, cannot be 10.1, cannot be 11, cannot be 12, cannot be 13, cannot be 22. This, the 10 to the power n, is called your order of magnitude. So you might have heard the word magnitude before when talking about earthquakes. So this tells about how big or how small the number is, depending if this n is positive, meaning it's larger, or negative, meaning the number is smaller. So any number that's written in this form, where a is greater than or equal to 1 and less than 10, times is always used with an x, that's how we know it's written in the scientific notation, 10 to the nth power. Order of magnitude, significant figure. Significant figure, order of magnitude. So let's take a look at an example of a number and if it's written in scientific notation or not. So my first example I want you to write down is 54.8 times 10 to the third. Is this written in scientific notation? What do you think? You're right, this is a no. 54.8 is too large. Okay, let me give you one more example to write down. 1 times 10 to the negative 15th. Is this written in scientific notation? Yes. The significant figure is between 1 inclusive and 10 not inclusive, and we have times the power of 10 to the negative 15th. This is a very small number. Let's look at another example. How about 0.84 times 10 to the 12th? Is this number written in scientific notation? No. The significant figure is too small. Remember, the significant figure needs to be equal to or greater than 1 and less than 10. Now let's go to our module. Everyone, let's go to page 28. Scientific notation. So some people think of scientific notation kind of like abbreviations when we're texting. It's just another way to show a value. So let's take a look at number 1. In ABCD, what's the only value here that's written in scientific notation? Remember, your significant figure, A, has to be greater than or equal to 1, but less than 10, with an x for multiplication, 10 to any power, positive or negative. Is A? No. That significant figure is too big. Is B? No. That significant figure is too, that's right, small. Is C? Yes. This is written in scientific notation. Is D? No. The significant figure is too large, greater than 10. So let's repeat ourselves on number 3, that any number in scientific notation must be written in the form a times 10 to the n, where a is greater than or equal to 1 and less than 10, and is called our significant figure. The multiplication is shown with an x, and we have 10 to the n, which is our order of magnitude. Okay, let's complete the charts in number 4. So let's take a look at the first table. It says complete the table below. We have a scientific notation column and a standard notation. Standard notation, like we said in the purpose, is just the decimal expansion. So taking a look at scientific notation, this is 6.345 times 10 to the 8th power. Because we work in the decimal system, which is a base 10, every decimal place is a value of 10. So 10 to the 8th means I'm going to get a bigger number, so I need to move the decimal to the right, and I need to move 8 decimal places to the right. Since I already have 3 decimal places taken care of to the right, how many more zeros do I need to add? 5 more. 6, 3, 4, 5, and then 5 more zeros. 1, 2, 3, 4, 5. And then count backwards by threes to add your commas. Some people, what they like to do is they like to show 6.345 and then move their decimal place point 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then go back and fill in their zeros. Sometimes I have so many loop-de's that I need to make and fill in my zeros, I make a silly error. So again, just count the decimal places. I know I'm moving the decimal point 8 total places to the right, 3 already spoken for, so I need to add 5 zeros as my placeholder. How would we say this number? Hundreds, thousands, millions. So this is 634,500,000. Let's do one more together. Let's move down to 3.2 times 10 to the negative 3. 10 to the negative 3 means our number is going to get smaller. That's right, negative means to the left. So we're going to move our decimal point to the left. So looking at my decimal point, if I'm moving to the left, I already have one decimal place taken care of, so I need to move a total of 2 more zeros. So I'd have 2 more zeros and 3, 2. Notice that doesn't include the 0 in the ones place. Otherwise, what we can do is we can look at this as 3.2 and then take our decimal point and move it 1, 2, 3 places. Same answer, just 2 different methods. Awesome. So again, remember, the positive exponent with the power of 10 means the number is getting bigger, and a negative exponent with the power of 10 means that the number is getting smaller. Let's look at the other side of the chart, and then I'll let you fill in the rest of the chart with your groups. So if I'm looking at standard notation, which remember is the decimal expansion, and I want to go back to scientific notation, I have to think about where the decimal point now needs to be. If I want my significant figure between 1 or equal to 1 but less than 10, where does my decimal point need to go? That's right, it needs to go between the 5 and the 3. Right now, my decimal point is at the far right of the number. So we need to move 3 decimal places to the right. To the left. But because we want these numbers to be equal to each other, this is 5.320, and to get back to my original number, which is 5,320, I need to move 3 decimal places to the right because it's a big number. So it's 5.320, or we could call it, we don't need this 0 here, we could call this 5 32/100ths times 10 to the 3rd. Let's do one more. Let's do a very small number. What's this number? Let's count over by the decimal places. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. So this is 54 millionths. Interesting. Really small. If I need to get my significant figure to be 1 or bigger but still less than 10, my decimal point is going to be 5.4. I know it's going to be times 10 to some power. And I need to go back to where my original decimal point is. There's 1, 2, 3, 4, 5, 6 decimal places. So that means this is 5 4/10 or 5.4 times 10 to the negative 6. I'd like you to finish the chart and fill in the blanks at the bottom of this page. You're finishing this page, and I'm going to give you 3 minutes to do it. 3 minutes working on with your groups. If you can please pause the video now and put 3 minutes on the timer. Thank you. Let's see how you did. these are the answers for what you should have just completed.